All right, this chapter is all about angles. The first lesson here is kind of an introduction with a couple different types of angles. Up at the top of each of these is a box. This one has a star with it, obviously. I'm trying to point these out. These are important things for you. These are all vocabulary words up here that you want to be able to identify basically by the end of the lesson. Just to kind of give you a visual representation, if we're talking about a right angle, it's exactly 90 degrees. So, for example, if I were going to demonstrate it's 3 o'clock, that would be a right angle. If I'm going for less than 90 degrees, a good example would be 1 o'clock, because that angle that's right in there would be less than 90 degrees, less than an L right angle. If I'm going for greater than 90 degrees, I could say it's 5 o'clock. This angle here would be larger than 90. And if I'm going for 180 degrees, we could use 6 o'clock because 6 o'clock would be a straight line, and a straight line is going to have 180 degrees in it. So how do we name angles? Basically, there's a couple ways. We can call this angle 3. We do have to use the angle symbol in front of it. We could also call this angle S, so we can name it by its vertex, which is kind of that hinge. If you kind of think about it as being a piece that kind of opens and closes, we can just name it by that. We could name this angle RST, so we follow an endpoint, a hinge, endpoint. Or we could also name this in the same method, TSR then. So those are kind of 4 ways to do it. This would also look like an obtuse angle if we wanted to get a little bit more specific. Over here we could call this guy angle 4. Angle M, because M is the hinge point. We could call it angle LMN, or we could call it angle NML, and this would actually be a straight angle because it's 180 degrees. 2 new terms for you potentially are vertical angles. 2 angles are vertical if they are opposite angles formed by the intersection of 2 lines. So essentially for this to happen, you need to have that X created, and 2 angles are vertical if they are across from each other. So for example, 2 and 4, 1 and 3 would be vertical angles. When you have this situation, you have vertical angles. The angles that are created are actually congruent. They have the exact same measure. So for example, if I told you that this was 110 degrees, you would automatically know because they're vertical angles that 4 is also 110 degrees. Adjacent would be sharing a common vertex, a common side, and they don't overlap. So 1 and 2 would actually be adjacent angles here because they share this vertex, and they also have this common side right here that goes down between the 2 of them. So if you kind of think about it, your house and your neighbor's house, you and your across the street neighbor are not adjacent. You're not next door neighbors. Adjacent angles don't necessarily have any particular angle relationship. They're not necessarily congruent. They could, however, become a linear pair, which we'll talk about in just a minute here. So if you look at the second page, just a little working with them, which angles are vertical. So vertical angles would be across from each other, so angles 1 and angles 3, and angle 2 and angle 4. And vertical angles are actually congruent, so remember they're going to have the same measure. Adjacent angles would be 1 and 2. You could also have 2 and 3. And you could have 3 and 4. And finally 4 and 1, which we'll write down as 1 and 4. We'll typically write them in chronological order, so go by numbers. If I'm looking at this, my vertical angles are going to be equal to each other, so this is going to be equal to this, and this will be equal to this. So I'm actually going to have to set up 2 different equations here. I'll start with the first one. So 2x plus 2 is equal to 130. And my other equation would be 3y minus 10 is equal to 50. And you're going to solve these just like we have been. So minus 2 is 128. We're going to get 64 degrees for x. 3y is going to be 60, so y is going to be 20 degrees then. If I look over here, these are vertical, so they're equal to each other. So 2x plus 4 equals 100 would be my equation. And I'm going to get 48 degrees then for x. One other relationship for this section today is a linear pair, and basically a linear pair happens if you have 2 adjacent angles that form a straight line. So if I look at this picture, my adjacent angles would be 1 and 2, 2 and 3, angles 3 and angle 4, angle 4 and angle 5, and angle 1 and angle 5. There is actually a set of vertical angles made by an X here, so angles 1 and 3 are actually going to be vertical. 4 and 2 would not work. If you look, these two sides do not form the same two sides. We don't have an X there, so we need two intersecting lines to do it. Same thing for 3 and 5. They're not the same two intersecting lines. Linear pairs here would be the two adjacent angles that form a straight line. If you look along here, I have a straight line that's made up by angles 1 and angle 2. So if I was told that angle 3 is 40 degrees and angle 5 is 47 degrees, could I fill in the measures of the other missing angles? So what I can do is, if you remember, these are actually a set of linears as well. They're not a linear pair, but they have three angles that make up a line. So we're actually able to use the same idea. So we could take 180, subtract 47, and subtract 40, and we're going to get 93 then for that one. So this angle right here is 93 degrees. If you remember, we said earlier that angles 1 and angle 3 were actually vertical. So 1 and 3 would have the same measures. So if 3 is 40 degrees, angle 1 is also 40 degrees. And we can figure out angle 2 here, because 1 and 2 are a linear pair. So we can take 180 and subtract the 40 from that, which tells me that angle 2 is 140 degrees. Solving angle puzzles are kind of like a puzzle. You pretty much just start to figure out pieces and use your relationships to help you.